Can you see? Hello?
Yes, sir. Yes,
Okay,
sir.
okay,
Yes, sir.
okay. See, we'll little bit go fast. Already we have lost 20 minutes. See, shallow foundation. So we have spoken about what are the different how to select a shallow foundation depending on different criteria, right? And while selecting, after selecting a foundation, while designing a foundation, or while choosing the type of foundation, you need to know basic two characteristics and study about two characteristics of foundation, that is, that foundation should not fail by shear, as well as the foundation should not fail by settlement. Now, coming to the next point, let us now try to understand this the different types of, see, we have said that foundation will fail by shear. Now what are the different types of failure you can have? What are the different types of failure you can have? Okay, so let us see the different types of failures. If you see for the foundation, then there are three types of failure actually. A foundation can fail by three types, okay, and the failures are called as or named as general shear failure, local shear failure, and punching shear failure. You should be remembering these three types of failures, okay? It's a very important term. So the types of shear failure of soil in soil for a particular foundation will be of three different types. One is general shear failure, one is local shear failure, and one is punching shear failure. Now before getting into the understanding of these three different types of shear failures, let us try to understand the load settlement curve. So see, this is your typical load settlement curve. See, for different types of shear failures, load settlement curves will be of different types. However, you try to understand what is actually load settlement curve. Basically, you see the load settlement curve is nothing but the curve you have earlier understood for your mild steel in solid mechanics, that is the stress strain kind of curve. It is a kind of curve like that only. So you see, one axis you are plotting load divided by area, and on the other axis you are plotting the settlement. That means how much, because of this load or per unit load per unit area, how much settlement is happening for the foundation. Now if you go back to the first type of shear failure, that is the general shear failure, you see, this is very important to understand. In 1943, Terzaghi has found out this thing using some experimentation, and he has seen that in case of dense kind of sand, that means where the relative density of soil is almost more than 70%, in such case he has observed that is when a footing is loaded or a foundation is loaded, then he has found that there are three prominent demarcable zones. Coming out while a footing fails, and in such case he has seen that he has done some observation, and from the observation you can observe it very clearly that in case of general shear failure, this is what is Terzaghi's observation, that just beneath the foundation, you see, just beneath the foundation there is a triangular zone, and this zone is actually a wedge shaped zone, a wedge, kind of a wedge. It is getting just attached to the foundation, the soil mass is just getting attached to the foundation, and because of this zone getting attached to the foundation, when the foundation is trying to come down like this, when the foundation is trying to come down along with this mass, you see what will happen to the other portion of the mass. Other portion of the soil mass will be just getting compressed, and you are going to get another prominent zone. See, both side of this wedge you are getting two prominent zones. Can you observe this? One is this zone and another one is this zone. So these two zones are basically, these two zones are these two zones are basically quite prominent. You see, quite prominent zone, and these two zones are called zone of radial shear. These two zones are called zone of radial shear. There will be a shearing force coming in the radial direction in these two zones, and you see beyond this zone also there is two prominent lines. Can you observe these two prominent failure lines coming, and these two prominent failure lines on these two side of this triangle or the spiral shaped failure zone, you see these two lines, this line and this line, it is coming, and this is actually called zone of radial shear. Okay, so when these three zones are demarcated perfectly, and also you see because of this kind of failure of soil, you see some portion of the soil is getting bulged out. This is called bulged out. You see, some portion of soil just above the ground level is getting bulged out, and this kind of failure actually Terzaghi has defined as general shear failure. Now you see, if you understand the details of general shear failure, you see the load settlement curve. So when you gradually increase the load, you see your settlement will gradually increase, and a sudden point will come. You see, at a sudden point will come with where you see after that point you don't see any increase of the load per area. However, if you increase any amount of load per area, then you see there will be sudden settlement. Okay, there will be sudden settlement. You see, after this QU region there is sudden settlement of the soil, and this kind of failure will be defined as general shear failure, and this has been defined by Terzaghi. We'll be understanding this general shear failure in more detail when we'll be talking about Terzaghi's bearing capacity equation. But before understanding Terzaghi's bearing capacity equation, you must understand what is general shear failure. So you see, in case of general shear failure, actually what you are getting three prominently defined and demarkable zones of failure. You see, there is a triangular zone, there is a spiral shaped zone, and then there is straight lines coming out here, and there will be bulging of soil. So when this kind of shear failure will happen, in which kind of soil you can expect such kind of shear failure will happen? So the common failure mode in dense sand and relative density greater than 70. So if the soil is kind of dense sand, and if the relative density of soil is more than 70%, in such case you may expect the soil will fail by this kind of general shear failure. Okay, and if the soil is failing by general shear failure, you can prominently now notice that there will be well defined failure surfaces. See, there is a triangular failure surface, then there is a spiral failure surface, and then there is a straight line like this, and also there will be bulging on the ground surface. There will be prominent bulging on the ground surface. So there will be bulging. So well defined failure surfaces will be getting developed. Then there will be bulging on the ground surface adjacent to the foundation. So here you see there is bulging of the ground at the ground surfaces. And also you notice from the load settlement curve there is a catastrophic failure. See, soil is behaving perfectly well, soil is behaving perfectly well. You are increasing load settlement, it is well settling, it is well settling, well settling. You, with the increase of load, it is well settling. But after this load, after this point, if you increase little bit amount of load, little amount of load, what will happen? There will be sudden increase of the settlement. You see, sudden drop of the settlement. And also the soil will not be able to carry any load. You see, the load by area is not increasing, it is coming down like this. So it will come up with a sudden catastrophic failure. So when it will happen? When the settlement reaches about 7% of the foundation width. So it is observed from experimental observations that when the settlement of the foundation reaches around 7% of the 7% of the width of the foundation, this catastrophic failure happens. So that means this settlement value, this QU, when you are reaching, this settlement value will be approximately around 7% of the foundation width. So this is actually your general shear failure, and this is one of the most common type of failure in foundation or in foundation soil. So general shear failure you should understand very clearly, because the formulation or the derivation of the bearing capacity or the capacity of soil, when you will be understanding, it will be primarily derived based on this Terzaghis general shear failure understanding. So Terzaghi is based on Terzaghi's general shear failure understanding of 1943. The theories will be developed, and again that will be developed by Terzaghi only. We will see that later. Now coming to next, the local shear failure. So what is local shear failure? So see, local shear failure, again you come to this. See, what is the difference? Can you observe the difference between general shear and local shear? You see, in case of general shear, you got three prominent zones of failure. One is this blue colored, one is this brown colored, and one is this kind of green colored zone. But you see, in case of local shear failure, you observe there is a zone of wedge. That wedge is attached to this triangular zone, is attached to this foundation. So yes, that prominent zone is here, that prominent zone is here. Oh, there is another one zone. You see, this zone is also present over here. This zone is also present over here. However, you see, the prominence of this zone and this zone is not there. So you see, in case of general shear failure, this is prominent, this is prominent. So you can see the prominent failure surfaces like this in case of general shear failure. Whereas when a foundation will be failing by local shear failure, you will not see this prominent failure surface inside the soil. As well, you will see that bulging of the soil surfaces is not happening that way as it was happening in case of general shear failure. You see, in case of general shear failure, there is lot of bulging outside the ground surface, whereas in case of local shear failure, you see, there is not that much of bulging. Obviously there will not be much bulging, because you see the prominence of this zone hasn't be it is not at all there. The prominence of this zone and this zone is not at all there. So the bulging of the soil outside the ground level will not be that prominent as it has happened in case of general shear failure. And if you see the difference between the load settlement curve for local shear failure and general shear failure, you will observe more difference. You see what is happening in case of general shear failure? It is increasing and then suddenly it is catastrophically failing. But in case of local shear failure, you see, it is, if you increase the load divided by area, that means if you increase the stress inside the soil, you see soil will be able to take up the settlement. So foundation will be settling. It will come to some point here, and beyond that also, if you increase the amount of load divided by area, that means stress inside the soil, you see the soil will be able to take up more amount of settlement, or the foundation will be gradually settling. And you see, in this case the failure was sudden and catastrophic. Just it came to this point and then just reduced like this. Whereas in this case you see, it is the gradual change from QU1 to QU, and then you see almost it is straight line, so gradually it is failing. So the settlement is very gradually increasing with some amount of increase in load beyond the maximum limit. And thus you can see that the failure in case of local shear failure will not be that catastrophic like the general shear failure. However, you also see the second part, you also see another one thing, that general shear failure will give you some indication, because if you see the soil outside the ground is bulging, you can expect that a general shear failure may come. However, you see, in case of local shear failure, as this bulging is not happening properly, so without your understanding, the foundation may fail. So general shear failure will give you some prior indication, as you can observe it from the outside, whereas you see the local shear failure may or may not give you any indication. Internally it will just change itself, the settlement pattern, and it will fail, and just the foundation will go down. So this is the challenge for a local shear failure. See, while considering this general shear failure only, Terzaghi has defined this local shear failure also, and according to his observation, the local shear failure, you see, the local shear failure is common for the soil where the relative density is between 35 to 70%. You see, if the relative density of soil is more than 70%, so if it is a dense sand, relative density is more than 70%, you may expect general shear failure in the soil. However, if the relative density is between 30% to 70%, then the soil which are in type of sand and clay, common failure type of sand and clay with medium compaction level, in such kind of soil you may expect that local shear failure will happen. Now second thing is, you see, the failure surface first develops right below the foundation. See, it first develops below the foundation, just below the foundation, and then it slowly extends outward with load increments. So it will first generate over here, then it will slowly extend, but this with the load increment, it's not that your failure surfaces will be as prominent as general shear failure. So you see, with the small increment, small amount of bulging, with the small amount of bulging as we have seen in the above figure, which may occur next to the foundation. So you see, small amount of bulging may come or it may not come, we don't know, but probably it will come. And when it will come? It will come when the settlement exceeds 8% of the foundation weight. You see, at 7% of the foundation weight, in case of general shear failure, you have observed there is a catastrophic failure, right? However, in case of local shear failure, you see, when the settlement almost is exceeding 8% of the foundation weight, when it is almost exceeding the 8% of the foundation weight, then only it will be showing the sign of bulging, isn't it? So when it is showing the sign of bulging, at that time you see, if it is general shear failure, then already the footing has failed. So when you see this bulging is happening, when this bulging starts, by that time you see, by that time footing has gone inside the soil, but by a considerable amount. So that is why local shear failure is kind of a very dangerous failure also, because it does not give you an indication from the outside, which general shear failure gives you prominently from your outside observation. Okay. Now see the significant settlement upon loading. So you see significant settlement upon loading. So if you increase the more load, it will be able to take more load, but around 15% of the foundation width. So the significant settlement will start. So here you see at this level, you see for general shear failure it happened around 7%, whereas for local shear failure at around 15% of the settlement, you will notice the total failure of the foundation will happen. But by the time you reach this 15% of foundation width settlement, you may not be able to visualize much of bulging outside. So because of that, internally the foundation will fail and it will just get inside the soil. Okay. So there will be gradual failure, but at sudden point there will be a jerk at this QU1, and then there will be sudden failure of the foundation. So I hope you have now understood the difference between local shear failure and general shear failure. See, primary difference you will be able to understand from these two figures. See, in case of general shear failure, you see three prominent zones you can observe: zone 1, zone 2, zone 3. This is your triangular zone is zone 1, this spiral separate zone is zone 2, and this zone is zone 3. And then there is bulging of surfaces, whereas in case of local shear failure, you see you get only two prominent zones. This one is zone 1 and the other one is zone 2. The third prominent zone, zone 3, is absent, almost absent in case of local shear failure, and also you see the bulging is not happening that way. So you now understand that the general shear failure will be happening to dense sand which is having relative density more than 70%, and if the relative density is between 35% to 70%, in such case you can expect the soil will be failing by local shear failure. Now coming to the third thing, that is the punching shear failure. You see, this punching shear failure hasn't been discovered or invented by Terzaghi. You see, after this 1943, after 20 years actually, in 1963, another one person, Vesic, has invented this punching shear failure, because Vesic has observed that whatever Terzaghi has said, many foundations are not failing because of not general shear failure or local shear failure. There is something else happening to the foundation. And you see, what is the else happening to the foundation? That else part, whatever is happening to the foundation, is basically happening because of punching shear failure. And what is punching shear failure? This punching shear failure, if you see, punching shear failure, can you observe the difference between now local shear and punching shear? You see, in the punching shear failure, you have only this triangular separate zone. The other two zones are absent. So instead of zone 1, zone 2 and zone 3, only you are getting zone 1 in case of punching shear failure. And this zone 1 is only being prominent in case of punching shear failure. And you see what happens in this case of failure. Because of the absence of this zone 2 and zone 3, you will not observe any indication of soil failure from outside. See, there is total absence of bulging in case of punching shear failure. And in such case, what will happen? There will be sudden failure of the soil or sudden failure of the foundation under the soil. And this kind of punching shear failure generally happens to the soil which are fairly loose. So you see, when you are dealing with very loose sand or very soft kind of clay, the relative density for which is less than 35%, in such case you may expect the soil will fail by punching shear failure. And the failure surface, if you see, in case of punching shear failure, it does not extends beyond the zone right beneath the foundation. You see, the failure surface, there is no extension like local shear failure, like general shear failure. You see, the failure surface is just below the just below the foundation. So failure surface, if you observe, it does not extend beyond the zone right beneath the foundation. So failure zone is just confined within the width of the foundation in a wedge shaped manner. And you see, there will be extensive settlement. You see, in case of local shear failure, the settlement started happening in a prominent way beyond the 15% of the foundation width, whereas in case of punching shear failure, you will observe that more than 15 to 20% of foundation width, there will be settlement of that amount, that more than 15 to 20% of the foundation width, with a wedge shaped soil zone beneath the foundation. And you will also find, just like the punching shear failure, just like the local shear failure, there will be a sudden jerk will be observed at around 6 to 8% of settlement of the foundation width. You see, in case of local shear failure, at around 8%, you have noticed that there may be some bulging, but you see, in this case, absolutely there will not be any bulging. In case of punching shear, absolutely there will not be any bulging out of the soil surfaces. And as the bulging out is not there, if bulging out is not at all there, then how do you identify from outside that foundation is settling and it will be failing? So it is, punching shear failure is kind of failure which cannot be observed from the outside. So you see, if you understand now the three different shear failures of soil, categorically general shear failure, local shear failure and punching shear failure, differentiation between these three can be given in terms of the relative density of soil, then in terms of the different failure zones getting developed beneath the foundation, then difference between the bulging surfaces which is coming out above the ground surface, and by the load settlement curve for each and every case. Okay, so these three things you must remember and you should be studying very well. Okay, it's a very important thing. If you do not understand general shear, local shear, then you will not be able to do well in foundation engineering. You will have to be very carefully understand this foundation, general shear failure and local shear failure. Okay, now let us go to the next one. Okay, now let us start understanding some terminologies. Okay, so we are understanding shallow foundation. Okay, so we will be understanding now some terminologies relating to the capacity, how much the soil can bear. So bearing capacity is nothing but how much the soil can bear. And what it can bear? It can bear how much of stress, or it can bear how much of settlement. So depending on that, we will need to understand typical terminologies in foundation engineering. See, the next two slides, whatever we will be discussing, they are very, very important, and very slowly we will be going. And if you have any question or doubt, you ask me. Okay, so very important terminologies we will be discussing. 6-7 definitions are there, and each and every definitions are very important. Okay, now see, the first terminology you need to understand, the gross loading intensity or gross pressure intensity. Gross pressure or gross loading intensity. So what is gross pressure or gross loading intensity? Let's say you are constructing a house and under the house there is foundation. So you see, for the building there will be a superstructure, and from the superstructure some load will be coming. As well, the foundation itself will be having some load. So the load of the superstructure, that Q superstructure, the load of the foundation superstructure, the load of the foundation, and the load of the soil. See, foundation will be underneath the soil. So on top of the foundation also there will be some soil. So on top of the foundation also there will be some soil. And when there will be soil on top of the foundation, in such case what will happen? The soil will also have some weight. So you see, if we sum up all these weights, that means the weight of the superstructure, weight of the foundation, and weight of the soil above the foundation level, and divide it by the area of the foundation, then the intensity of loading or the pressure intensity, whatever we will be getting, that we will be defining as gross pressure or gross loading intensity. Is it clear? Now you see, so how do I define it? We will be defining it like the total pressure at the level of foundation. See, at the level of foundation, foundation is where? Foundation is at the bottom of the ground. So when the foundation is at the bottom of the ground, on the foundation the load from superstructure is coming. So load of the superstructure plus load of the foundation plus the soil load, whatever the foundation is supporting, that divided by the total area of the foundation, that is going to give you gross pressure or gross loading intensity. So definition wise it will be total pressure at the level of foundation, including the weight of superstructure, foundation, and the soil above foundation. I think this definition is very simple to understand, and we will define this with the term Qg. Okay, we will define with the term Qg. Okay, now let us come to net pressure or net loading intensity. Who is coming? Who is this? Umesh Kumar Datta, Utkarsh.
Yes, sir.
Who is Umesh Kumar Datta? Again and again coming. He is
So
from
roll number 41, civil 1.
Civil
Yes,
one.
sir, civil 1.
So he hasn't got this thing. Means the invitation he hasn't got.
Maybe some network problem.
Okay, maybe network problem. Maybe that may be the case. Okay. Okay. Let's see. See, now next let us understand the next definition: net pressure or net loading intensity. Net pressure or net loading intensity. Net pressure or net loading intensity. So what is net pressure or net loading intensity? You see, definition wise, mathematically if you see, it's very simple. So you have calculated the gross pressure intensity, that is Qg. Gross pressure intensity Qg you have understood. Now if you subtract the soil pressure, that is the overburden pressure. And what is overburden pressure? You remember from soil mechanics, overburden pressure is nothing but your gamma into d. And what is d? D in this case is the depth of the foundation. So the foundation at a particular depth is supporting some amount of soil which has got some unit weight, that is gamma. So gamma df will be the overburden pressure due to the soil. So if you want to find out the net loading intensity or net pressure intensity from the gross pressure or gross loading intensity, what you will have to do, you will have to just subtract from the gross pressure intensity the amount of what is called, this is your overburden pressure. So definition wise, what you say, net pressure or net loading intensity So see, deformation of the soil below the base of the footing is caused only by pressure over and above that which existed before the construction of the footing. This you should be very clear. So soil was there. When you construct a foundation, what you do? You dig the soil, right? And then inside the soil, inside that dug up place, you put the foundation and then you fill it up with the soil again. So soil was already there inside, right? And you have excavated the soil, then you have constructed the foundation, and again you put the soil inside it. So you see, deformation of the soil below the base of the footing is caused only by the pressure over and above that which existed before the construction of footing. So you see, the soil which was existing before construction of foundation, that already has deformed the soil, right? That already has deformed the soil. So the superstructure and the footing, when you construct, at that time you excavate the soil and put it inside. So if you take the difference between the gross pressure and overburden pressure, and what is overburden pressure? Overburden pressure is nothing but your gamma into dF. At the base of the footing, that will be termed as net pressure or net loading intensity. I think you should be mathematically, if you understand, it is very simple to understand. So you see, gross pressure intensity is nothing but load of superstructure. Who is coming and going, coming and going? Subhodip Chatterjee. Is he from your class, Subhodip Chatterjee?
Yes, sir.
Civil 1?
Yes, sir.
Okay.
Yes, sir.
Admitted. Okay. So you see, difference, so superstructure, foundation and soil weight divided by area of foundation. If you do, you get gross pressure intensity. Now you see, foundation, soil was already existing before the construction of foundation. So what you will have to do? You will have to just subtract the weight of the soil. And how do you subtract the weight of the soil? Unit weight of soil multiplied by the depth of the foundation. So that is actually your overburden pressure. You subtract from the gross pressure, you are going to get net pressure or net loading intensity. Now comes the important term, very important term, that is ultimate bearing capacity. Ultimate bearing capacity. And what is ultimate bearing capacity? Ultimate bearing capacity is nothing but, you see, it's very important to understand. You try to read this definition properly. See, if the load at the base of the footing, is gradually increased, see, we have spoken about this QG, right? You have spoken about this QG. So what you will be increasing? You will be, your foundation, let's say your foundation weight is same, your soil weight is same, but your superstructure weight may increase, right? Because superstructure you are constructing, the superstructure will be carrying the load of human being, of different kinds of live loads and other kinds of loads. So if you think about a condition where your superstructure load is gradually increased, then what will happen? That will create more pressure on the soil. So if the load at the base of the footing is gradually increased, then what will happen? A stage will be reached. There will be a particular time will come, a stage will be reached, when at that time what will happen? The load will cause a shear failure in the supporting soil. Multiple time I have repeated this, right, in the previous lecture, that the load will cause a shear failure. That means if you are gradually increasing your load on a footing, and how you increase the load? You are increasing the load from your superstructure. So if you are increasing the load on the superstructure, your soil is having some capacity to take that much amount of stress, right? Because of the foundation is taking the load, and ultimately the foundation is transferring the load to the soil. So when the load will be transferred from the foundation to the soil, soil will be getting stressed. And as you have now understood that when the excessive stressing of soil will happen beyond some level, and what level? Beyond the permissible shearing stress of soil, then what will happen? The soil will fail by shear, and that is what is actually the ultimate bearing capacity of soil. So you see, if the load at the base of the footing is gradually increased, then there will be a stage coming when you will see that load will cause the shear failure of the supporting soil, and in that case the maximum gross intensity of loading, you see, gross intensity of loading means this QG, this gross intensity of loading, that means you have increased your Q superstructure, you have increased your Q superstructure, and you have increased it to such a level, that soil cannot bear much more than that. So in such case, whatever QG you will be getting, that QG will be termed as QU, and that will be calling as ultimate bearing capacity. Okay, so the maximum gross intensity of loading that the soil can support before it fails in shear is called ultimate bearing capacity. Is it clear? Now you see,
Yes.
very important definition, this ultimate bearing capacity. You cannot forget during your total career of civil engineering, this ultimate bearing capacity. So you see, ultimate bearing capacity that way is very simple to understand. It is the gross load intensity, and gross load intensity is nothing but your Q superstructure plus Q foundation plus your Q soil divided by the area of the foundation. And that gross load intensity comes to such a level, when the gross load intensity comes to such a level that fails the soil underneath the foundation in shear, that much gross load intensity will be termed as ultimate bearing capacity of soil, and that will be called as QU. Okay, and this ultimate bearing capacity, you see, just beside I have written one note. See, ultimate bearing capacity, see, you cannot find out it just like this, that it's not that simple as this, that how do you determine that what will be the ultimate bearing capacity of the soil? In that case, what you will have to do? You will have to increase the superstructure load until the soil fails, and if the soil fails, your structure will fail. So will you be doing testing like that? No, you will have to do some other methodology to find out. So it's not that simple to find out the ultimate bearing capacity, and for that Terzaghi has given some formulation. We'll discuss it later, but you must understand this ultimate bearing capacity is not only dependent on the property of the soil. See, just it is not dependent on cohesion and friction of the soil, angle of internal friction of soil. It is not only dependent on cohesion and angle of friction of soil, but also it will depend on the characteristics of the foundation. What is the type of the foundation? That means, what is the shape of the foundation? What is the size of the foundation? What is the depth of the foundation? What is the mode of loading of the foundation? What is the presence? What is the effect of presence of water table underneath the foundation? All those things will come into picture while you will be finding out the ultimate bearing capacity of foundation, because you see, you cannot experimentally directly find out always the ultimate bearing capacity of soil, right? You will have to go with some kind of theoretical formulation, and you need to find out it. And while finding out ultimate bearing capacity using Terzaghi's bearing capacity formulation, you will observe that it will not depend only on the shear strength characteristics of soil, that is, it will not only depend on cohesion and angle of internal friction of soil, it will also depend on the characteristics of foundation. That means what is the length of the foundation, breadth of the foundation, where is the foundation placed, and what is the mode of loading, how the load is placed on the foundation, whether it is vertically placed, whether it is inclined way placed, whether it is directly horizontally placed, and also along with all those things also it will depend on whether the presence of water table is there underneath the foundation or it is above the foundation level. Depending on all such criteria, your bearing capacity is going to change and it will be getting affected. Is it clear? Okay. So I think, oh, who is coming and going? Ravi Kumar. Who is Ravi Kumar? From Civil 1?
Yes, sir.
Yes, sir.
Admit.
Yes,
See,
sir.
Yes, sir.
everyone should be able to come in, right? Because I think you have all the email IDs, whatever is given to those email IDs. I have sent the invitation, right? So everyone should go, should be able to participate, right? I don't know what is happening. Maybe because of connection issues this is happening, right? See, in the previous class, what I have seen, people are giving attendance here. You also give it in some other class? Utkarsh?
Yes, sir.
You also give through this chatting window, you also give this attendance?
No, sir.
No, you don't give.
In
Means in the civil 2 I have seen people have written their roll number and name in this chat window, all
no,
one
sir.
by one.
In another class, sir is calling name, and
Ah.
we unmute and say yes.
Okay. Anyway, you just attend that quiz whatever I am sending. Okay. See, in the previous day I have seen only 21 person has attended the quiz. All should attend that one. Okay. Then I will be able to give the attendance. Okay. Anyway, see, so should I stop today here? Because if I proceed further for this will take another half an hour maybe. So it will be difficult to explain. So should I? So today let us stop here. Any question if you have, you can ask. Okay. You have any question?
What is settlement?
What is settlement? Big question. See, settlement, I think you have learnt it about settlement while you have studied soil mechanics. See, settlement is nothing but the deformation of soil. It is the deformation of soil. Okay. So suppose you take something, or take a brick. Let's say take a brick, and you place it on loose sand. Just take a heap of sand and take a brick, and you just try to just keep the brick on it. What will happen? The soil will be getting displaced and brick will be just little bit getting down inside the sand, right? Now if you press it with your hand with huge amount of force, what will happen? The brick will go inside the sand, and that is settlement. Have you understood? Settlement means
Yes.
basically
Yes,
the
sir.
deformation under the footing actually. Okay. So settlement is a term which is basically both way true, that a foundation will settle because of the load, and when the foundation settles, along with the foundation, soil will also go down along with the foundation. That is what you have seen in this case of general shear, local shear. See, this is your footing, and this footing, let's say at this level, then if the load is coming, you see, along with the foundation, this wedge will also go down, this wedge will also go down, and that is actually settlement. Okay, anything else?
No, sir.
Okay, so should I stop today?
Okay.
Okay, okay, so let us stop today, and in again on next class we'll be discussing more in more detail about the other definitions, and then we'll enter into we'll talk about Terzaghis bearing capacity equation, very important. Okay, so next week 2 classes will be very important, don't miss. Okay, thank you. Okay.